Now here, if each branch is something like this, this incoming current is IK. K is nothing but branch number. If it is the first branch, it will be I1. This ISK is source current. If it is the branch number 1, then it will be IS1. Is it right? Then current in this branch, how we will get the current in this branch? Now, this branch voltage is the Vk. What is the formula for current in any branch? Current in any branch is given by the formula I is equal to the voltage across that branch, which is V, divided by the impedance of that particular branch, which is V divided by Z. Is it right? If we are interested in the calculation of this current, this Vk is the voltage of that branch, which is this V. But what is the Yk? Yk is nothing but 1 upon Z. 1 upon Z is the admittance. Is it right? Now here, in terms of representing these parameters in terms of the impedances, here I have tried to show this parameter in terms of the admittance, that is Yk. It is 1 upon Z. This current in this particular branch is Vk into Ik. And if we will apply the KCL at this particular node, which is I have tried to mention it as the X. If we are applying the KCL at node B or node X to be exact, this should be the node X. If we are applying the KCL at this particular node, which is the X, how is the equation? Incoming current is equal to outgoing current. This is the incoming current. This is outgoing. This is outgoing. I is the outgoing current. This ISK is outgoing current. This indirectly, this IK is very same as this I. What is the I? This is Vk into Yk. This is Vk into Yk. And this ISK is nothing but it is ISK. This is general equation. If I will prepare this equation for the branch number 1, how is the equation for the branch number 1? For the branch number 1, that equation will become this Ik, K will become 1, means this I1 is equal to V1 into Y1, this is V1 into Y1, because current in this particular branch, plus it is IS1, which is the current of this particular branch. Similarly, for the branch number 2, the same equation will become I2 is equal to V2 into Y2, which is plus IS2, because this will become the source 2. For the branch B may be any number, maybe 5th, maybe 8th, maybe 100. For this branch number B, the equation will be, this is IB, which is equal to VBYB plus ISB, where VB is nothing but this IK for the B branch. This VBYB is nothing but VKYK for the branch number B, and this ISB is nothing but ISK for that branch number B, and we will get this equation. And if we are organizing all these branch equations in the matrix form, if I am arranging all these equations in the matrix from I1, I2, I3 for up to IB, this is the branch matrix or branch current matrix, which is IB, which is column matrix. Is it right? Similarly, in this particular case, multiplication of these two, VB into YB, this is VB into YB. This YB is the admittance matrix, branch admittance matrix, and this VB is nothing but this YB is nothing but branch admittance matrix, and this VB is nothing but that is branch voltage matrix. Is it right? Which is this VK. This is V1, V2, V3 is nothing but these are the branch voltages. This is branch voltage matrix. Plus IS is nothing but this column matrix. Means indirectly what I meant to say, if we are organizing these equations in the matrix form, we will get equation something like this. I will discuss about this, which is the equation number 2. That is IB is equal to YB into VB plus it is into IS. Is it right? But we know that row-wise addition in the reduced density matrix, already we have discussed this. How is the row-wise addition? Row-wise addition is nothing but A into IB, which is equal to 0. Just we have discussed that. That is nothing but it is same as the KCL. Already we know about this KCL. Is it right? This equation. And we will substitute the equation number 2 in equation number 3. Is it right? How is the equation number 2? This IB, which we have previewed in the last case. How is the IB? That I will show. This IB is equal to YB into VB plus IS. If we are substituting in place of IB these values, which I have tried to show here in this particular case, this is indirectly we are doing this, indirectly we are applying the KCL and we are putting the values of the branch currents. This here A into this IB and IB is replaced by these terms, that is YB into VB plus it is IS. And if we are simplifying this equation, this A into YB, this multiplication, A into YB into VB, this is VB, this is the first term, this A into multiplication of these terms, plus This A into IS, this is plus A into IS, which is equal to 0. That is nothing but equation number 4, this equation. As well as, but from the column-wise addition of the reduced incidence matrix, we know that this branch voltage is nothing but transpose of the matrix A into the node voltage in this equation we have. Means what we will do, we will substitute this equation here, that is in the VB, and we will analyze this complete equation, and in that case we will get the final equation which is useful for the calculation of the voltages and currents using this particular method, which is nothing but the reduced incidence matrix method. Now look at here. Putting the equation number 5 in the equation number 4, we get what we are doing. We are putting that equation number 5. This A into YB, this term is the same. That equation number 4 is a transpose, A transpose, because what is the VB? That VB value we have substituted here. This equation for the VB, which is equal to, what is the equation of the VB? The equation of the VB is nothing but A transpose into VL. Perfect. Hope I listen. So here in this particular case, in this particular case, if we are substituting that particular value here, and if we will simplify this equation, this A into YB into A transpose into BN, this complete thing is same as this A into IS. Just we are changing the nomenclature. This complete multiplication, I am naming it as a YN. This VN is as it is. This A into IS is as it is. What is this YN? This YN is nothing but to reduce the incidence admittance matrix. Just like we have the YB. YB is the branch impedance matrix. In the similar way, we are preparing one matrix which is the admittance matrix for the reduced incidence matrix. Is it right? Yes, finally we have this equation. This YN into VN, it is minus A into IS. Means we will use only this equation for the calculation of the current. What is the equation? YN into VN, which is equal to minus A into IS, this relation, and using this relation we are in a position to find out the calculation of the current in all branches, as well as we are able to calculate the value of the node voltages, as well as we are able to calculate the value of the branch voltages. Is it right? Where this YN is nothing but A into YB into A transpose. We have to find out all these values, and then we are in a position to work out that calculation.